Hello and welcome to my Pre-Algebra Big Ideas review series. This video covers Chapter 8, Section 2, titled Volumes of Cones. By the end of this video, you'll be able to answer the question, how can you find the area of a cone? You'll have to review recent lessons regarding finding the volume of a cone, and you'll be finding the height of a cone. You will also have a chance to look at a real-life problem that will be helping you to round out your concept of the space usage inside of a cone. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So let's get into it. Okay, for a key idea, we're going to look at the volume of a cone. So how do you describe the volume of a cone? Well, the volume of a cone is 1/3 the product of the base times the height. So just like we did in the cylinder, it was base times height. Now we've added in the 1/3. So whatever the volume of a cylinder is, a cone of those same dimensions of height and diameter, 1/3 of that is the volume of the cone. And it shows it right here that we have the area of the base. It's our same base. We're used to this base. We've used it before, which is what? What is the base? It's pi r squared, right? That's base times the height, and then you take 1/3 of it. It couldn't be any simpler than that. Height of the cone, the base of the cone multiplied together, and then divided by 3. Okay, for example 1, finding the volume of a cone. Find the area of a cone and round to your answer to the nearest tenth. Let's see. We're showing here the equation right off the bat, which is here is the volume of the cone is equal to 1/3 the base, which is pi r squared, times the height. In this case, we've already figured the radius in. And what was the radius? We see that the diameter from the bottom here, from one side of the circle to the other, is 4 meters. So that must mean that the radius is 1/2 of that. So we have 2 squared times the height. And the height we know is going to be 6 meters. So in the next line, we have the volume of the cone is 1/3 pi times 4 times 6. And that is 24 divided by 3, which is 8. Right? So that's what it was. If you look at it, it's 24 divided by 3 times pi is equal to 8 pi. Okay? That's what you have here. So 8 pi, and it is meters cubed. Don't forget, we're always going to be cubing, but it's meters cubed after you have the square meters here and the single unsquared, or the unit meters by themselves. So what does that come out to? It comes out to the volume of the cone is 8 pi meters cubed. That's the exact height. And as you know, in the past, we've talked about the approximate value, and that is when we convert pi to its decimal equivalent, or its decimal approximation of 3.14. Then we get 8 times 3.14 comes out to 25.1. So the answer here is the volume of the cone is exactly 8 pi meters cubed, or approximately about 25.1 meters cubed. And I notice that there's an error up here, and I'm going to fix it before I post this. But you might not even see this. I'm not sure what you're going to see. Anyways, this is find the area of a cone. No, it's find the volume of a cone. Okay, example 2, let's find the height of a cone. So find the height of a cone, round your answer to the nearest tenth. So it says the volume here, and I have a little c right here. I like to do that because now you know I'm talking about the volume of the cone. Anyways, it is 956 cubic feet, and we know that by looking over here in the picture, and it says right here that the volume of the cone is 956 feet cubed. And we know our formula is the volume of the cone is going to be 1/3 the base, 1/3 the base times the height. And so again, the volume of the cube is 1/3 pi r squared h. We know what r is. They've given it to us. It's right here. 9 feet is the radius. We don't know h. They want us to find h. So when we fill in the numbers, we're going to see 956 feet cubed is equal to 1/3 pi times 9 squared times h. 9 squared is 81. So in the next line, we're going to have 956 feet cubed is equal to 27 pi. 27 because 9 squared is 81 divided by 3 is 27. 27 pi right there times h. Well, they're wanting us to find h, so let's look for it. So what is h? H is 956 feet cubed, 956 feet cubed, divided by 27 pi feet squared. 27 pi feet squared. It's right here, 27 pi feet squared. And your answer is going to end up 11.3. And it says exactly, I'm not sure if there's a rounding going off into here, but it says still equals, maybe approximate because there was a rounding on. I'll have to get the calculator and determine if that happened or not. Anyways, it's 11.3 feet. Okay, so the height of the cone is about, and this could have been a squiggly lines here, about 11.3 feet. Okay, exercises. This is the A. There's a couple of them, probably exercise B you'll be following. We're going to do this on your own. And it says, find the volume or height of the cone. Round your answers to the nearest tenth. So we have the formula here. Again, we have volume is equal to 1/3 pi r squared h for the volume of a cone. And on the other side here, we have a little, we tell you that the volume of the cone is 7,200 yards cubed, or cubic yards. And that comes off of the picture. And then you're going to fill in the formula and work it from there. When you get back, we'll do it. We'll look at it with the solution. Okay? So there you can go ahead and do that. Okay, so now let's look at the answers to this. So on the first one, we have this upside down, looks like an ice cream cone. And so we have the volume of the cone is 1/3 pi r squared right here, h. And we're going to fill in the value. So what is the radius of the cone? Well, from the very center to the edge, it says 6 centimeters. So we have 6 going to be squared in here. And 15 is the height. Here's the height right here. Goes right from the vertex right to the center of the circle. That's the height. So now when we write the next piece of this equation, we're going to have the volume is 1/3 36. 6 squared is 36 times 15. And if we do that, if we work that out, it's going to be, the volume will be 180 pi centimeters cubed, or cubic centimeters, or about 565.5 cubic centimeters. And how did we get 565.5? Well, we multiplied 180 times 3.14. And that's how you get and it was rounded to 0.5. So there's the answer to the volume of this cone, 565.5 cubic centimeters. How about the yards over here, this larger cone for sure? It says that the volume is 7,200 cubic yards. And then we write the equation out. The volume of the cone is 1/3 pi r squared h. So we fill in the values. 7,200 yards cubed. That's the volume. We know it. It says it volume right here. So we're going to write the volume right here. We're at the volume. This piece. Right here. Times 1/3. 1/3 times pi. Times 15 squared. Here's r squared. 15 squared. Here's the radius from right here to right here. That's the radius. 15. We square it. And multiply by h. And that's what we're looking for, is the height. So 7,200 yards cubed is equal to 1/3 times pi times 225, because 15 squared is 225. Okay. A third of 225 is 75. So 7,200 cubic yards is equal to 75 pi square yards times h yards. Okay. So now we're finding h. We have 7,200 cubic yards divided by 75 pi yards squared. And when you do that, you're going to get h is equal to 96, right here, 96 pi yards. The height is in yards. And that's approximately equal to, because you're going to divide now 96 by pi, you're going to get 30.6 yards. So the height of the cone is about 30.6 yards tall. Okay, in example 3, we have a real-life problem, a real-life application. These are fun because you get to see something in real life, a way to use this information. You must answer a trivia question before the sand in the timer falls to the bottom. They want to know when this timer is going to be completely empty is what they're looking for. Sand. I'm going to fix that, S-A-N-D, right here. I'm not going to write on it. The sand falls at a rate of 50 millimeters cubed. So it's a volume of sand that's pouring through this little spot in the center. And it's 50 millimeters cubed per second. How much time do you have to answer the question? Well, they want you to answer it before it falls to the bottom. They'll tell you how many, you're going to have to figure out how many cubic millimeters there are. And then that's per second, and then you'll know how many seconds you have. So let's look at it. So the volume of the cube is 1/3 base times the height. We know that formula. The volume of the cube is 1/3 pi r squared. We know that formula, and times the height. And what is the height right here? It's 24 millimeters. They're showing it right here, 24 millimeters. And right here, it's 10 millimeters is the diameter, is the radius at this point. You go up higher, it could be 30 millimeters, way at the tippy top, if it had sand filled to the top, but it doesn't. It's to this point where it's 10 millimeters is the radius. So now when we fill in the equation, the volume of the cone is 1/3 pi times 10 millimeters squared times 24 millimeters. Well, we know that 10 millimeters squared is going to be 100 millimeters cubed, okay? And 24 is times millimeters, so that's going to give us a cubed value when we're all done here. So 1/3 pi is 3.14 times 100, that's 10 squared, times 24. When you multiply all this out, you're going to get the volume of the cube is 2,513 millimeters cubed. So find the time before the time runs out. Well, how do you do that? Well, you know how many millimeters cubed are in there, and you know that every second, 50 millimeters falls through it. So here's your conversion factor. We've done those just recently. The conversion factor is right here. Okay, 1 second per 50 millimeters cubed. So we're going to take 2,513 millimeters cubed, and we want to convert to seconds. And if you saw my last video where I said the units you're converting to is on top. So this is seconds per millimeters cubed. 1 second per 50 millimeters cubed. We want seconds, so you put the seconds on the top and the millimeters cubed, in this case, on the bottom. That way the millimeters cubed cancel, and you're left with seconds right there on the top. So now it's 2,513 divided by 50. 2,513 divided by 50, right, or that 50 right there. And then it's equal to 50.26 seconds. Okay, 50.26 seconds. So in about 50 seconds, the timer will run through and be gone, empty. You'll have run out of time. How's that? Okay, exercises B on your own. Solve each from example 3 above. What if the sand falls at a rate of 60 millimeters cubed per second, how much time do you have to answer the question? That's before the timer runs out. And the other question is, what if the length of the sand timer is 12 millimeters? The length of the sand timer is 12 millimeters and the radius is 5 millimeters. So we're going to change a couple items. How much time do you have to answer the question? Well, go ahead and take your time. And, well, before you go out, I think you can read this. And so I put the old picture in there. 30 millimeters, 10 millimeters is the radius, 24 millimeters was the length of the sand timer, I guess is what they're calling it. So it says, what if the sand falls at 60 before it was 50? So at the very end, you're going to solve the same problem, and you're going to just divide, you're going to divide by the 60 instead of 50. That's what it was before. In this other problem too, it says the radius is 5 millimeters. Well, that didn't change. But the timer is 12 millimeters. So it was 24. We cut it in half. So it's 12. It's 12. Okay, so go ahead and work on it on your own. And then when you get back, we'll just take a look at the answers, okay? Okay, so now that you've had some time to do that, what if the sand falls at a rate of 60 millimeters cubed per second? How much time do you have to answer that question? Well, we start off as always. And I like to say this, write the formula, write the equation, whenever you're working in mathematics, it's a magic what it does for you. It helps center your mind on the formula, on the problem. You can look at it and see if it's different from what you came from, make sure that you didn't mess in it. You fully understand what's negative, what's multiplied, what's divided. That's the importance of writing it before you start solving the problem. So here we wrote it out. We have the formula. V of the cone is 1/3 the base times the height. And you know that. I don't have to even write too much about it, but here it is 1/3 the base time, right here, the 1/3 the base times the height. And we know that we can expand the base to pi r squared. And now in this line here, we have 1/3 pi times 10 squared. Right there, it says 10 millimeters. We can still see it's 10 millimeters. Okay. And the next one, the radius is going to change on us. But right now it's 10 millimeters. And it's 24 millimeters high. So when we multiply this out, we're going to get, again, like we did the last time, 2,513 millimeters cubed. And then this is the time before it runs out. The constant now is 1 second. So now we're going to convert per 60 millimeters. Before, I think it was 50. So now 1 second per 60 millimeters. We're converting to time. How soon will it run out? So as I said, you want the time units on the top. So 2,513 millimeters cubed times 1 second per 60 millimeters. So it takes 1 second for 60 millimeters to fall through the tube. So if we divide right here, if we divide this 2,513 by 60, we're going to get T equal to 41.88 seconds, or about 42 seconds. About, there's that word again, about. So that says that this is an approximate number, approximately 4120, because we did do a multiply times pi in here. So it's always going to be approximate after that. The other one here, the other problem says, what if the sand timer was 12 millimeters long and the radius 5? How much time do you have to answer the question? Well, same formulas, everything. Now down on this line here, we see that the volume of the cube is 1/3 pi 5 squared times 12. New numbers. 1/3, 3.14 times 25. 5 squared is 25 times 12 is 314. Look at that, 3.14. Kind of interesting. Anyways, millimeters cubed, approximately. We multiplied by our pi, changed it to 3.14, and now this is approximate. Actually, this should have been approximate right here too, but it's okay. It's approximate here. Approximate 314 millimeters cubed. Find the time before the time runs out. So the constant here is 1 over 50 millimeters. We change it. I don't know that anything's changed. I figure this is 50 from the old example. They didn't say to use the time, the quantity from the new version of the timer. So that comes out to 314 divided by 50 is 6.28 seconds. About 6 seconds. Okay? Now, had we kept it at the 60, we would have divided 60 into this, and it would have been, well, 60 would have went into 30 about 5 seconds, or near to the 5 second mark. So there you have it.